Hey guys, this is Mrs. Harbin and welcome to Advanced Math Lesson 1.5, Solving Equations. Before we get started, let's talk about our biblical correlation. We have this verse from Genesis 6:15 through 16 that says, "This is how you are to build it. The ark is to be 450 feet long, 75 feet wide, and 45 feet high. Make a roof for it and finish the ark to within 18 inches of the top." Now, these are God's instructions to Noah for how to build the ark. And what this verse shows us is that people, even in Noah's time, were using precise and exact measurements. Math has always been important, not only for solving problems in a math class, but for practical application and use. So our goal today is that you can use, our goal this year is that you are not just learning these so that you can pass this class, but you are learning and seeing and practicing these applications in real life. Our lesson objective is this. The student, you, will identify the properties of equality and solve equations by applying the properties of equality. So let's talk for a minute about what an equation is. An equation is a mathematical sentence stating that two expressions are equal. So we have this expression, 2x, and this expression, 3y plus 2. We have an equal sign there in the middle, so this is an equation. It's a mathematical sentence stating that these two expressions are equal. The most common equation is probably just one with numbers, the easiest one. 4 equals 4. We know that that's true because 4 is the same as 4. Those two things are equal. So an equation can be simple, like 4 equals 4, or it can be a little bit more complicated and involve variables and all different kinds of terms. If we were to solve this equation to find that variable, we would find that x is equal to 4. And that's what we're going to be working on today, solving these equations. A value of the variable that makes the equation true is called a solution, or root. In 8x equals 16, what value of x would make that solution true? Well, if x were 1, 8 times 1 is 8, and 8 equals 16 is not true. But if x were 2, 8 times 2, that equals 16. 16 equals 16, that would be true. 2 is a solution or a root of x. Now, when we solve equations, we can't really just go through and try every number that exists because there are an infinite number of numbers. And so we've got to have a procedure or a process for how we can figure out what this variable is, the value of the variable, without just plugging and chugging all the different numbers that exist. So let's talk about some of the properties that are going to help us do that. The first property is called the reflexive property. And the reflexive property of equality just says that whatever is on the left side of the equal sign equals whatever's on the right side of the equal sign. We saw that with 4 equals 4. You saw that when you were younger with things like 1 plus 1 equals 2. And now you're adding some variables. So 2a equals 16. The reflexive property says that whatever is on one side is the same as the other side. If we do anything to the left side, we have to do the same thing to the right side to keep that balanced, to keep it equal. The symmetric property of equality says that if a equals b, then b equals a. So if 1 plus 1 equals 2, then we can easily just flip that around and write that 2 equals 1.1 plus 1. That's our symmetric property of equality. The transitive property of equality says that if a equals b and b equals c, then a equals c. Now, the easiest way to kind of explain this is probably not in terms of math, but in terms of the animal kingdom. So let's take a look at this. If a dog, and we're going to use equal sign because equals just means is, if a dog is a mammal, that's our b variable, and a mammal is an animal, I'm not going to write the whole word here, animal, then we know that a dog is also an animal. Okay, we'll see this transitive property of equality throughout algebra, that if A equals B and B equals C, then A, logically, must also equal C. The addition property of equality says that if A equals B, then A plus C equals B plus C. I talked about this earlier when I talked about making the equation balanced. So imagine that you have A and B, and you've got them sitting on this scale, like a scale that you would use when weighing things in science class. Okay, if an equation is equal, then it's balanced. Well, if I add over here on the left side of this scale, if I add a C, then my equation is no longer balanced. I've added something extra in this side. In order to keep that balance, I have to also add it to this side, over here. And now my equation is equal again. So that is our addition property of equality. Whatever I add to one side, I have to add to the other to keep it balanced. Another property is the multiplication property of equality, and this is similar to the addition property. If A equals B and I multiply A times C, then my equation is not balanced. I have to do that to the other side as well. So A times C is the same as B times C. That's our multiplication property of equality. Whatever we do to one side, we have to do to the other side of our equation. Imagine that scale, and we need to keep it balanced. Two equations are called equivalent equations if they have the same solution. This should remind you of the word equal here. Okay, they are equivalent equations if they have the same solution. The addition and multiplication properties of equality, properly applied, can produce equivalent equations. Let's take a look at this equation and see if we can figure out the variable. Let's solve for x. We have negative 3 times x plus 2 equals 4 times x plus 18 minus 1. So what should we do? Well, we could plug and chug 1 and see if that works, and 2 and see if that works, and 3 and see if that works, but that might take us a while. So let's use the things we've learned in previous lessons. First, let's get rid of these parentheses with the distributive property. When we distribute the negative 3 to what's inside the parentheses, and the 4 into what's inside the parentheses on the other side of the equation, we end up with negative 3x minus 6 equals 4x plus 72 minus 1. Let's see if we can combine some like terms. I see that 72 and negative 1 are both numbers, like terms, so we can combine those into a positive 71. Now what I can also do is subtract this from one side and move it to the other side so my x's are together. In order to move things from one side of the scale to the other, think about this. Again, let's go back to our scale drawing. Let's say I have a 3x here, but I want to move it to the other side. What do I need to do? Well, the first thing I need to do is take it off of this side and put it over here on this side. Add it to this side. I'm going to take it away from one side and add it to the other side. So let's do that. The way that we take away or remove a negative 3x is by using the opposite, a positive 3x. Our properties of addition tell us that two opposite numbers combined together, so negative 3 and a positive 3 are opposite, two opposite numbers combined together equals 0. So that's how we get rid of that 3x. We use the opposite. But if I take it away from one side of this scale, in order to keep things balanced, I'm going to add it to the other side. So let's move this over here. 4x plus 3x, and that's where our 7x came from. So I've got a term with a variable, and then I've got two constant terms with no variable. How could I move this 71 over here so that it's on the same side as the other constant? We're going to use the opposite. I have a positive 71, so I'm going to use the opposite to cancel that out. And whatever I do to one side, I have to do to the other. And that leaves us with 7x on one side and negative 77 on the other side. Now, I still don't have that x all by itself. Remember, that's the whole goal here of solving for an equation, is that I want to get that x all by itself. Let's erase this a little bit here. Well, this remember 7x, the operation that's being done is 7 times x. 7 times x. So I've got to do the opposite. Up above, the opposite was addition and subtraction. What's the opposite of times? If you said division, you are correct. So I'm going to divide both sides by x. Using our properties of division, both sides by 7. We know that 7 divided by 7 is 1, so they cancel each other out. We've got 1x. And then we've got 77, negative 77 divided by 7 on the other side. And when we conduct that arithmetic to that operation, we end up with x equals negative 11. If we wanted to make sure that our answer was correct, we could take this negative of 11, put it back into our original equation, wherever there's an x, and plug and chug. And we should end up with two things that are exactly the same, equivalent expressions. An equation can be cleared of fractions, if you have fractions in there, by multiplying both sides by the common denominator, preferably the least common denominator. You can also clear decimals by multiplying by a power of 10. So let's take a look at how this would work. And I've got 3 fractions here, and my 3 denominators are 4, 3, and 6. The least common denominator is the smallest number, or the smallest product that these are all a factor of. Well, the factors of 3 are the products of the factor 3 are 3, 6, 9, 12, 15, 18, 21, etc. 4 is a factor of 4, 8, 12, 16, etc., etc., etc. So 5, 12, and 12. And 6 is a factor of 6, 12. So all 3 of these numbers are factors of 12. So the way that I can clear these fractions is to multiply both sides by 12. Remember, 12 is just 12 over 1. And when we multiply fractions, we multiply the top and we multiply the bottom. So we're going to distribute that 12 to everything inside the parentheses on both sides. When we do that and we simplify, what we end up with is 3x plus 4 times x minus 1 equals 2 times x plus 3. If you're not sure how we got this 3x, we looked at 12 and 4 and we simplified. 4 goes into 4 one time and it goes into 12 3 times. And we did the same thing with the 3 and the 6 on the other parts of our equation. We need to distribute again to get rid of those parentheses, and when we do that and combine like terms, we get 7x minus 4 equals 2x plus 6. Well, let's gather all of our x terms on one side and all of our coefficient terms on the other side using our opposites here. The opposite of positive 2x is minus 2x, so we're going to do that to both sides. And we're going to use the opposite of negative 4 to move that 4 over. It's positive 4 on both sides. When I've done that, I get 5x equals 10. I still need to get that x by itself. Remember, this is 5 times 10, and the opposite of multiplication is division. So we're going to divide both sides by 5 in order to get the x by itself, and we end up with x equals 2. To check our work, we could plug that 2 back in, substitute it back into our original equation there, and see if we get equivalent expressions, which in fact we do. An excluded value is a value of a variable that would cause an expression to be undefined. As an example, we can never have 0 on the bottom of a fraction, in the bottom of a rational number. So if we plug in a value and it gives us 0 on the bottom of a fraction, that's an excluded value. We can't include it because it would cause our expression to be undefined. When solving equations, try to follow these steps. First, clear the equation of fractions by multiplying both sides by the least common denominator. Then simplify both sides of the equation by combining like terms. Once you have all your like terms combined, you can collect the terms containing the variable on one side and all the other terms on the other side. Factor the desired variable out of the sum if necessary, and divide both sides by the coefficient of the variable. Again, we're trying to get the variable by itself. Go ahead and solve this one on your own. Pause and see if you come up with this answer. We cleared our decimals. We're combining like terms, and we find out that n equals 7. Great job, guys.